Hi there. We are currently on Project 3, Lesson 14. So we're on the fourth lesson for Project 3, and we're still dealing with crimes in Blotterville. So we've got 4 questions here. The first one is the inequality that compares the robbery rates on the east side of Blotterville to the west side is y is greater than 4x. Which of the following properties apply to the graph of the given inequality? So let's go ahead and just graph this inequality so that we can easily answer these questions, okay? All right. I've got my coordinates here. And remember we had y is greater than 4x plus 0. That was one of the options. So I know that 0 is my y-intercept here. And then because this is a greater than symbol and not a greater than or equal to, I'm going to have a dotted line. All right, so we know we've got a point at 0 and 0, but when x is 1, y is going to be 4, okay? And when x is 2, y is going to be 8. All right, so we've got a pretty steep slope here. All right, so now I've definitely got plenty of points that I can make this graph. No, it's dotted because I don't have the or equal to sign, okay? Now, now I just need to decide which side of this line gets shaded, okay? Well, the key is this greater than symbol. Y is greater than 4x. So when it's greater than, we can shade above the line, okay? So if x is 0, then y can be 1. If x is 1, then y can be 4. Well, it actually has to be greater than 4, so it can be 5, 6, 7, or 8. So it's anything on this side of the line, and it can't include the line. Okay, so the answers that make sense here, based on the graph we just created, the y-intercept of the borderline is 0. Okay, there is no shading. That's not true. There is a dotted line at y equal 4x. That's true because it's not greater than or equal to. The y-intercept of the borderline is 4. No, we already decided that was 0. There is shading below the borderline. Nope, actually it's above the borderline. Okay, and the solid line at y equal 4x, actually we decided it was a dotted line at y equal 4x. So these 3 answers describe our line, and we're going to be asked to describe a line here in a little bit. And so the things we want to consider are where it crosses the y-axis, whether or not it's a dotted or solid line, and where the shading occurs. So those are the things that really describe an inequality in 2 variables. Okay, let's go ahead and move on to the next one. The inequality that represents the sum of the number of robbery suspects from the north and south sides is, as we determined earlier, 4x plus 2y is greater than or equal to 24. This inequality is in standard form. Rearrange it so that it is in slope-intercept form. Okay. So to do that, I need to get it into y equals mx plus b, or y is greater than or equal to mx plus b. Okay, so I need to move this 4x to the other side. So I'm going to subtract 4x from both sides, and I end up with 2y is greater than or equal to negative 4x plus 24. Okay, so what I did there, let's just take that inequality sign out real quick. We have 4x plus 2y equals 24. I subtracted 4x from both sides. They go away here, and then I just rearranged here because I wanted in y equal mx plus b form. So I put the negative 4x before the 24. That's all I did. Now I still need to divide by 2. I am dividing to isolate that variable y, so it's important that I consider the sign of the coefficient of my variable, the sign is positive, so I don't need to switch the sign of the inequality, okay? But I do need to divide every quantity by 2. So I get y is greater than or equal to negative 2x plus 12. Fortunately for me, that is indeed one of the answer choices. Okay. Now we need to graph this. Y is greater than or equal to negative 2x plus 12. And I'm just going to go ahead and write it in a place that it scrolls with us. Y is greater than or equal to negative 2x plus 12. Okay, so what I know is I have a slope of negative 2, which leans left, and I'm crossing the y-intercept. So this is my b value, and this is my m value, okay? Slope of negative 2 and crossing the y-intercept at positive 12. So let's scroll down, and every single one of these graphs does that, okay? So now we need to find some other things that distinguish these graphs from each other. And one thing that I can see right off the bat is this greater than or equal to, okay? So this greater than or equal to means that I have a solid line instead of a dotted line. So now I can eliminate this one because of the dotted line and the last one. So the second and fourth answers can be eliminated simply because of the dotted lines. So I can go now to my solid lines and see which one makes sense. But my computer seems to have frozen up. There we go, maybe. Okay, I can actually see the right answer here, so that helps. This solid line has the solution set or the shaded area above the line, which is great for me because I want y is greater than or equal to the line that's represented by negative 2x plus 12. Okay, so any value of y over here is going to be greater than negative 2x plus 12. So it's above the line. So this right here is indeed my correct answer. Okay. And that was the third one. As you can see, this one here has it below the line. So that's the difference in the two. Okay, last question here. 6x minus 3y is greater than 15. Explain how to graph the inequality and describe what the graph looks like. Well, first we should go ahead and put this in y equals mx plus b form. So when I do that, this one is a little bit tricky. I'm going to go ahead and subtract 6x from both sides. So I get negative 3y is greater than negative 6x plus 15. Okay. Now, in order to solve and isolate y all by itself, I need to divide by a negative 3. Okay. Here, we are dividing by a negative 3 in order to isolate this variable y. Okay, when I do that, I have to switch the sign of my inequality. So now I have y is less than negative 6 divided by negative 3 is 2x minus 5, because 15 divided by 3 is a negative 5. So that is the line that I'm looking at. So you can offer that little description as to how you get to y equals mx plus b form. Now what we'll do is go ahead and type in here y is less than 2x minus 5. Okay, this means that our line, our border line, has a slope of positive 2 and a y-intercept of negative 5. Okay? As y is less than this, the shaded area will be below the borderline. And we'll go ahead and borderline is dotted so that it is not included in the solution set. Okay, so it's going to look something like this. Okay, it's going to cross down here at negative 5, and it's going to have a slope of positive 2. Okay, and it's going to be shaded down here below the borderline, and forgot to indicate on my graph that it's dotted. It's not a solid line. Okay, so it's a dotted line at y equal 2x minus 5, and it's shaded below. All right, that's all we have for lesson 14. Come back for the final lesson in this project.